Hello, friends. Today we are looking at how to interpret the meaning of the slope and the y-intercept in the slope-intercept form of an equation when we are given a situation, a word problem. So we have an electrician charges a set fee for every house call and then charges an hourly rate depending on how long the job takes. The total cost of the electrician's services can be determined using the equation C equals 65t plus 105. Where t is the number of hours the electrician spends at the house working. What is the y-intercept of the equation, and what is its interpretation in the context of the problem? So, of course, as we know, we can typically write our slope-intercept form as y equals mx plus b, and it's okay to substitute in different variables, different letters for the y and the x. So in this case, we've got c equals 65t plus 105. It still lines up, if you notice. Instead of y, we have c. Instead of x, we have t. The other stuff is still the same. So our y-intercept then must be this 105. And then what does that represent? Well, let's see what our options are. The number of hours the electrician spends at the house, the total cost for all services, the hourly rate charged, the set fee for the house call. All right, let's work through each of these options and figure out what we can get rid of. So the number of hours the electrician spends at the house. Well, hold on. That's t. It says t is the number of hours the electrician spends at the house. So it certainly can't be that one. The total cost for all services. Well, it says the total cost of the electrician's services can be determined using this equation. So we would assume that then c is total cost. So it's not going to be that one. The hourly rate charged, there's nothing in the problem so far that says specifically that it's not that. However, if t is the number of hours and 65 is attached to t, that's going to be your slope. That's going to be the hourly rate because that's dealing with hours. It is directly related to the amount of hours he spends there. So the last one we have is the set fee for the house call. That is what we are looking for. Our y-intercept, our standalone number, does not affect the variable. The variable does not affect it. It is always going to be our starting value or our flat fee for a lot of problems like this. It is the thing that is not related to the variable at all. If there's a set fee, that's going to be your y-intercept. Let's try another one. Serenity is moving and must rent a truck. There is an initial charge for the rental plus a fee per mile driven. The total cost of renting the truck can be modeled by the equation C equals 50 plus 2.75 m, where m is the number of miles driven. What is the y-intercept of the equation, and what is its interpretation in the context of the problem? So again, we typically write y equals mx plus b. However, we can write it as y equals b plus mx, and it looks like that's what's going on here. We have c equals 50, a plain number, plus 2.75 m. So the 2.75 is what is attached to the variable. That must be our slope. So that means our y-intercept must be that 50. Now, what does that represent? All right, so there's initial charge for the rental plus fee per mile driven. Total cost can be modeled by the equation, which means probably that total cost is C. And then it tells us M is the number of miles driven. Okay. So we know that there's an initial charge, we know there's a cost per mile, we know that C is the total cost, and we know that M is the number of miles driven. So let's look at our options. The initial fee to rent the truck. That could be it for sure. But let's just double check. We'll come back to it. The cost per mile that Serenity drives. Well, the 50, the B is not attached to the the variable, the number of miles, so that doesn't seem like it. The total number of miles driven, that can't be right because we know that that's M. We are told that. And the total cost for renting the truck for the day, that has to be C. So the only one that it could be is the initial fee to rent the truck. And like I said last problem, typically speaking, our y-intercept is going to be our starting value, our initial fee, our flat fee, whatever, something that is not affected by the number of miles or the amount of hours or whatnot. Let's do one more of these. Kevin needs to lease out a music studio to record his new album. Very cool, Kevin. The studio charges an initial studio use fee. Okay, so we've got an initial fee plus an hourly fee for each hour in the studio. Total amount Kevin would have to pay to use the studio for T hours can be determined using the equation P equals 100 plus 50T. What is the y-intercept and what is its interpretation? What does it mean? So again, our y-intercept is always the number that is not attached to the variable. It's just kind of hanging out, whether that's in front of the variable term or after, whether it is y equals mx plus b or it is y equals b plus mx. Our y-intercept is always going to be the number without the variable. So that must be that 100. And then what does it represent? Let's see. So one of our choices is the total price of using the studio for the day. But according to the problem, how it sets up, that must be P. So that must be the total equation. We have to figure that out before we can figure out what the total price is. The total number of hours Kevin used the studio? Well, no, we know that T is hours. So it can't be that. The initial fee of using the studio, that could be because it's not affected by anything else, but let's just double check our last one. And the additional price per hour of using the studio. Now again, that has the key words per hour. That's our slope. That's attached to the variable being hours. So our only applicable option here is the initial fee of using the studio. What if we change gears and move to interpreting the slope? So we've got Nathaniel. When Nathaniel left his house this morning, his cell phone battery was partially charged. The charge remaining in Nathaniel's battery as a percentage can be modeled by the equation B equals 52 minus 6.5t, where t is the number of hours since he left his house. What is the slope of the equation and what is its interpretation in the context of the problem? Now, by this point we should be very familiar with our y equals mx plus b, or y equals b plus mx. Sometimes you will see it either way around. M is slope, that is always attached to the variable. So what is attached to the variable here? Negative 6.5. So that must be our slope. And then so charge remaining, that's B. T is the number of hours. All right, so then slope. How do we interpret what slope means? So could be the charge of battery when Nathaniel left his house. I mean, maybe, but if we're attached to the variable, if we are related to the number of hours, it's probably going to be something different because that was our flat fee. That's the thing that doesn't change regardless of how many hours. Doesn't matter how many hours he's been away, what percentage it was at when he left is going to stay the same. So it's probably not that one. The rate that Nathaniel's phone gains charge per hour. Okay, so we've got our keywords per hour. So this might be a tempting option. However, be careful. Our slope is negative. He is losing phone battery. He is not gaining phone battery. So that one is there to trick us. The number of hours until Nathaniel's phone dies. Interesting. That's not going to be it either because t is the number of hours. We'd probably have to solve this equation for t to figure out how many hours it would take. And then the percent charge that his phone loses each hour. Now again, we have our keywords each hour or per hour, and this one is talking about losing. This one is negative. So that's going to be our answer for this one. Let's try another one. Oh, that's the same type of problem. All right. Harper just lit a new candle and then let it burn all the way down to nothing. The length of the candle remaining unburned in inches can be modeled by the equation L equals 15 minus 1.5t, where t is hours since the candle was lit, and the length of the candle remaining unburnt, that's going to be L. What is the slope of the equation? What is its interpretation? Slope is always attached to the variable. Does not matter what the equation looks like. It's always going to be attached. The only thing to watch out for is whether or not it is negative. In this case, we've got 15 minus 1.5t. So it's the 1.5t that we want, and it's going to be negative because we are minus 1.5t. And then what is that talking about? That is talking about, excuse me, the number of hours until the candle burned fully. No, because t is hours. It's related to the number of hours, but it is not the number of hours on its own. The original length of the new candle? No, that would be our y-intercept. That's the original value, your starting point. So that would be that 15. We are dealing with slope. We are dealing with something that changes per hour. The total number of candle inches that have burned? No, because that would be something related to L, because L is the length of the unburnt candle. So we'd figure out something to do with L to figure that out. Or the number of inches of candle that burns per hour. Now we've got our keywords per hour, and we're talking about candle burning down, so that seems to be the one that we want. It's changing per hour, and it is not the hours itself. It is the number of inches that burn per hour. So that's what we want. We'll do one more of these. Samuel is in the business of manufacturing phones. He must pay a daily fixed cost to rent the building and equipment, and also pays cost per phone produced for materials and labor. We've got our equation C equals 225p plus 900. That's the total cost in dollars of producing P phones a day. Excuse me. What is the slope of the equation, and what is its interpretation in the context of the problem? By now, we should be very comfortable with finding our slope from an equation that looks something like this. It's going to be attached to the variable. That means that our slope is 225 because P is the variable here. Just because it's not an X, it's still a variable. And then what does that represent? So we've got a daily fixed cost, we've got a cost per phone, we've got total cost, and we've got P phones a day. So one of our options is our slope, our 225, is the total cost to produce all of the phones. No, that's C. We've already established that. The additional cost to produce each phone, that could be it, because we're talking about, it's related to P, which is phones in a given day, but let's just double check our other options. The fixed cost for rent and equipment, that's going to be our y-intercept, not our slope. The daily fixed cost, the starting value, the initial fee, the flat thing that does not change regardless of our variable, that's our y-intercept. So that is referring to the y-intercept. The number of days to produce all of the phones, there's nothing here talking about number of days. Yes, we've got a daily fixed cost and how much it costs in a day, but we don't have anything about the number of days. So I think that one's in there to throw us off. And the number of phones produced in a day. Well, no, again, we were told in the problem P is phones. So while the 225 is attached to the P, it's related to the P, it is not the variable itself. It is just dealing with the variable. So it's something to do with days, but it is not days themselves. It is something to do with phones, but it is not the phones themselves. So it is going to be the additional cost to produce each phone. We'll talk more about this in class, shall we?